Okay, so here we have just a basic Wio demonstration there, but what we're going to do today is some machine learning. So let's get a fresh Wio going, and let's go to model creation. So I would like to do the motion one first, and I got to give it a name. Wio motion. And there we go. So this is the code that gets flashed to the Wio. What's nice here, we're not using the Arduino IDE at all. Here are the three labels we're going to eventually work with, and this is going to show where the data is. Here are the buttons. And I've got the Wio upside, I have to program in a little bit to get the Wio upside down. But this is button A, B, and C, A, B, and C. So let's throw in that little bit of extra code to put it upside down. That's just to get this cable out of the way of my recorder. I noticed with this code that it never actually says anything on the Wio that it's ready to go. So I'm just going to throw in Wio ready because without that you just don't know what's going on with the screen. So let's fire this on. I've already got it connected, so it should just be upload. Yeah, it's on the serial port. And what we're going to do is we're going to flip the Wio. We're going to make it do like a wave motion, and we're going to do idle, and we're going to do a bunch because machine learning wants a ton of data. So what's it say there? Wio ready. Now A is the flip, and I think I said this button was the A button, that button. So all we're going to do is hold it reasonably steady and flip it a bunch. One thing. Shoot. This is 5 seconds. While that's deleting, as I said before, once I tried this with 1 second and it had an error. So I tried more data. Now I'm going to just try it with 2 seconds. Let's upload it. And look how easy this is. And it's actually really quick. I think it might be a little quicker than the Arduino IDE at uploading stuff. And it'll be interesting to see what it's like on Windows because I'm on a Ubuntu machine. Anyway, it's ready now. We've got none of these labels, so let's give it a try. I'm just going to do the C button first with the stay still, just to see. So I'm holding it down, and let's see the little thing come up where it says it's processing. Now, what I don't really get is whether I should wait each time. So I'm looking at maybe 10 samples per. That's definitely, you can see it right here, it's loading up. This is what, I don't know whether I should do a bunch of them. It doesn't seem to have a huge speed improvement. Now I'm going to turn it a little bit this time, and there's that first one. Okay, so I've got 12 seconds of each, so that's 6 samples of each. That might not be enough, but let's give it another try. I've got my large there. It's saying number of training samples. I'm going to crank it up to 100. If it sets it down to 30, I don't mind. And once again, I'm going to pause this. It's going to show a bunch of information here in the log, but it probably will take 5 minutes or so. So pause. So here's what happens. I'm surprised it's got the Eon compiler. That's cool. TF Lite. It's profiling. So this is the information it spits out. Here's the loss value. Loss is kind of like how bad your model is. So you want the loss to get smaller, and there it is getting smaller. And it spits out a ton of information. And then at the end, it goes through some epochs. And anyway, what you're looking for is this model training report, because as soon as that shows up, you know it's done. You can also look at your sample data, and you can actually pick different ones to look at. And it does mention whether it's a flip or whether it's the idle. See, the idle is much smaller graphs. These are the accelerometers, blue, green, and red. I can probably guess which color is which axis, but whatever. So we want to go to the model training report, and this is very familiar to me with edge impulse, loss of 0.14. These all at 100%. It's really rare. I'm just good at this. The inference time, 8 milliseconds, the amount of RAM, flash usage. So the big deal here is model deployment. So what that does, it's very unimpressive because it just flips you to another spot. And here's a spot where you're like, what do I do? I don't know if I should pause for this. There we go. Used in programming. So here it gets you to programming, and it's super confusing. What the heck do I do right here? So what I'm going to do is just show you the absolute simplest thing you can do here is this, which as far as I know, puts the information into the loop. Oh, I'm going to have to set up my I'm not going to do the display or anything. I'm just going to put it into the serial port, I think. And here's the cool thing. Who cares if it doesn't work? I think this is going to just put it into the serial monitor. So what we've got here, let's clear the space, see which way it goes. There we go. That's a little bit better. So it's giving me the percentages. I should have maybe put a line in there. So now when I flip it, or when I do a wave, their idle's high, their wave is high, right at the bottom, right where my mouse is, wave is high. Let's tidy it up a little bit. So let's move that into there, and let's use model, and model results of current prediction. We need to do this whole display thing again. So it would be nice if I could copy this from a different part of the program. So display, remember I'm doing it upside down just because it's easier for me. So what do I want? I need a couple display things. I need the size to be big, and I need display to print in the main loop, and then to grab this and print the result. Now putting these in these things are kind of tricky sometime. So let's try. I'm going to pause, see if I can fix that up. Okay, so what I've done, changed it around a little bit, have the same startup stuff, have my reading of the accelerometer, and then I fill a rectangle at 0, 0, 100 width, and 50 height. That's the little rectangle there to delete the old one. And then I come up with the current prediction at location 1010, so it's just a little in. And it's still going to the serial monitor, so there we go. And you can see the data there, but you can also see it on the screen. So idle is idle, it's just sitting there. And then flip works, and then the wave there. And there is a little time lag because they are 2-second analysis. There we go with the wave. So all good. Took a little bit to get used to the Scratch programming, but all in all, pretty cool. The screen's already there. I think it's really cheap. I think it's under 40 bucks. We also have a lot that can be explored with the Raspberry Pi connectors there. It's a pretty cool device.